Laboratory flasks are vessels which fall into the category of laboratory equipment known as glassware. In laboratory and other scientific settings, they are usually referred to simply as flasks. Flasks come in a number of shapes and a wide range of sizes, but a common distinguishing aspect in their shapes is a wider vessel body, and one narrower tubular sections at the top called necks which have an opening at the top. Laboratory flask sizes are specified by the volume they can hold, typically in metric units such as milliliters or liters. Laboratory flasks have traditionally been made of glass, but can also be made of plastic. At the opening, at top of the neck of some glass flasks such as round-bottom flasks, retorts, or sometimes volumetric flasks, there are outer tapered ground glass joints. Some flasks, especially volumetric flasks, come with a stopper or cap for capping the opening at the top of the neck. Such stoppers can be made of glass or plastic. Glass stoppers typically have a matching tapered inner ground glass joint surface, but often only of stopper quality. Flasks which do not come with such stoppers or caps included may be capped with a rubber bung or cork stopper. Flasks can be used for making solutions or for holding, containing, collecting, or sometimes volumetrically measuring chemicals, samples, solutions, etc. for chemical reactions or other processes such as mixing, heating, cooling, dissolving, precipitation, boiling, or analysis. List of flasks. There are several types of laboratory flasks, all of which have different functions within the laboratory. Flasks, because of their use, can be divided into reaction flasks, which are usually spherical and are accompanied by their necks, at the ends of which are ground glass joints to quickly and tightly connect to the rest of the apparatus. The reaction flask is usually made of thick glass and they can tolerate large pressure differences, with the result that you can keep two both in a reaction under vacuum and pressure, sometimes simultaneously. Some varieties are multiple neck flasks, which can have 2 to 5, or less commonly, 6 necks, each topped by ground glass connections are used in more complex reactions that require the controlled mixing of multiple reagents. SCHLENK flask is a spherical flask with a ground glass opening and a hose outlet with a vacuum stopcock. The tap makes it easy to connect the flask to a vacuum nitrogen line through the hose and carrying out the reaction either in vacuum or in atmosphere nitrogen. Distillation flasks, which are intended to contain mixtures, which are subject to distillation, as well as to receive the products of distillation. Distillation flasks are available in various shapes. Similar to the reaction flask, the distillation flasks usually have only one narrow neck and a ground glass joint and are made of thinner glass than the reaction flask, so that it is easier to heat. They are sometimes spherical, test tube shaped, or pear-shaped, also known as a Gjeldal flask, due to its use with Gjeldal bulbs. Reagent flasks are usually a flat-bottomed flask, which can thus be conveniently placed on a table or in a cabinet. These flasks cannot withstand too much pressure or temperature differences, due to the stresses which arise in a flat bottom. These flasks are usually made of weaker glass than reaction flasks. Certain types of flasks are supplied with a ground glass stopper in them, and others that are threaded neck and closest with an appropriate nut or automatic dispenser. These flasks are available in 2 standard shapes. Round-bottom flasks are shaped like a tube emerging from the top of a sphere. The flasks are often long neck. Sometimes they have the incision on the neck, which precisely defines the volume of flask. They can be used in distillations, or in the heating a product. These types of flask are alternatively called Florence flasks. Flasks with flat bottom. Cassia flasks, for the analysis of essential oils and aldehyde determination, approximately 100 milliliters, neck graduated 0-6 a 0, 1 milliliter. Erlenmeyer flask, introduced in 1861 by German chemist Emil Erlenmeyer, is shaped like a cone, usually completed by the ground joint. The conical flasks are very popular because of their low price and portability. Volumetric flask is used for preparing liquids with volumes of high precision. It is a flask with an approximately pear-shaped body and a long neck with a circumferential fill line. Dewar flask is a double-walled flask having a near vacuum between the 2 walls. These come in a variety of shapes and sizes. Some are large and tube-like, others are shaped like regular flasks. Evaporating flasks entered, pear-shaped, with socket or with flange. Powder flasks, for drying of powdered substances, pear-shaped, with socket. Retorts are simplified distillation apparatuses, with long, downturned necks, and round bases. They have largely been replaced by condensers. Bar 1/4 CHNE flask or sidearm flask or suction flask, they are a flat-bottomed flask, but made of very thick and resistant glass. They are usually a cone shape, similar to the shape of an Erlenmeyer flask, but also have side neck, usually affixed to the side, 2/3 up from the bottom. The flasks are used to cooperate with vacuum aspirator or vacuum pumps in the vacuum filtration, or as additional security during the distillation and other processes carried out under reduced pressure. Culture flasks for growing cells are designed to improve aeration by including baffles that aid in mixing when placed on a shaker table. Many of these flasks can be wrapped in a protective outer layer of glass, leaving a gap between the inner and outer walls. These are called jacketed flasks. They are often used in a reaction using a cooling fluid. Legal issues: like many other common pieces of glassware, Erlenmeyer flasks could potentially be used in the production of drugs. In an effort to restrict such production, some U.S. states have made possession of common flasks illegal in schools without permit, including Erlenmeyer flasks, as well as chemicals identified as common starting materials. See also, Erlenmeyer flask, references, Memorandum of Understanding between the Texas Department of Public Safety and the Texas Higher Education Coordinating Board 080107 THECB State TXUS, external links, media related to laboratory flasks at Wikimedia Commons.